I recently bought an RP360 guitar processor from Digitech, and while I really like the unit, it could use some more foot switches to make it really functional. Digitech does make an external foot switch called the FS3X for this exact purpose, but before I ordered one, I decided to look up the schematic.
That's all there is? Hold on a minute.
It's a very simple circuit consisting of 3 foot switches, 2 diodes, and a jack. And since I had all the parts in stock, I thought I'd build my own. To start off, here's the parts and tools I used to build this project. You'll need a Hammond 1590XX aluminum box, 3 momentary normally open foot switches, a 1/4 inch stereo jack, a 1/4 inch stereo patch cable, a couple of 1N 4001 diodes, and some stick-on rubber feet. For wiring, I used 2 different colors of 22 gauge stranded wire. Now for the tools you'll need: a hand drill, a 1/8 inch drill bit, a step drill bit for the larger holes, and an automatic center punch to mark them out. Some wire strippers, a soldering iron, and some solder. You'll also need some masking tape or blue painter's tape like I have here. Now that we have all the parts, let's start building. I started out by laying out the parts on the box to see how everything would fit. Once I was satisfied with the positioning, I made up a drilling guide and taped it to the top of the enclosure. I then used my center punch to carefully mark the center of each hole. Next, I clamped the enclosure down securely and used a 1/8 drill bit to drill some pilot holes. Now I can use the step drill bit to widen the holes to 1/2 inch. Next, I covered the rear of the enclosure with a piece of tape. I then used a ruler to mark the center of the enclosure roughly in line with the right-hand foot switch. Once again, I used the center punch to mark the hole location and a 1/8 inch drill bit to drill a pilot hole. I then used the step drill bit to enlarge the hole to 3/8 of an inch. And the drilling is done. This next part is optional, but I always like to make my projects look nice with some custom graphics. Here's how I made them. First, I opened up Inkscape and came up with a design. Once the design was done, I printed it out on my inkjet printer using matte photo paper. Next, I used my Silhouette Cameo to precisely cut it out. I really like the Cameo for this type of work, but by no means do you need it. A pair of scissors will work fine. I then laminated the graphics with a standard office laminating machine. Using some scissors, I carefully cut around the edge of the panel, leaving a little bit of the lamination so it doesn't come apart. To attach the graphics, I used some 3M 468 MP adhesive. With some scissors, I trimmed a small square slightly larger than the panel. Then I peeled off one side and stuck the panel to it. Next, I used the scissors to trim off the excess. Now I was ready to stick the panel to the enclosure. I used some blue painter's tape to make a hinge that would allow me to lift up the panel, remove the adhesive backing, and then stick it down right in place. Next, I used an X-Acto knife to cut out the holes. With the front panel finished, it was time to install the switches and the jack. Now I needed to identify the tip, ring, and sleeve terminals on the jack. To do this, I like to plug in a cable and use my multimeter on continuity mode. With one probe, I touch a section of the plug at the end of the cable. With the other probe, I touch each terminal on the jack. When I hear a beep, I know I've matched the two sections together. Now that I've identified the tip, ring, and sleeve terminals on the jack, I can start wiring. I'll start by using some black wire to connect one terminal on each switch to the shield terminal on the jack. Notice how I'm chaining the wires together. Simply cut and strip a length of wire and solder it in place. If you have more than one wire going to a terminal, make sure you put both wires in place before you solder them. Once the solder joint is done, cut off the excess wire with some wire cutters. Now I'll connect both diodes to one terminal on the up switch. The diode has a small stripe on one end, and I'll make sure that that side goes to the switch. Once that's done, I'll take the other end of one diode and connect it to the jack's ring terminal, and the second diode I'll connect to the tip terminal. Finally, I'll use some red wire to connect the down switch to the ring terminal and the mode switch to the tip terminal. To finish up, I'll screw on the back cover and then stick on some self-adhesive rubber feet. Now I can use the up and down controls to change patches on the RP360. If you like these type of projects, make sure you follow Notes and Volts on YouTube, Facebook, and Twitter. And once again, I'd like to give a special thanks to my Patreon supporters for helping to make this video possible.